Number 14, the series n equals 1 to infinity of 4 plus 3 to the n all over 2n. So I'll start with the numerator here. I know that 4 plus 3 to the n is bigger than just 3 to the n. And to make it look like my original series, I'll divide everybody by 2 to the n. So this 3 to the n over 2 to the n is really 3 halves, all raised to the n. So it looks like a number raised to the n, so it's a geometric series. And the series that I'm using is smaller than the one I was given. So does this diverge? My r is 3 halves, which is bigger than 1, so this will diverge. So we are all good to go since the smaller series diverges. My write-up is going to be 0 is less than 3 halves to the n, which is less than 4 plus 3 to the n over 2 to the n. And my series n equals 1 to infinity of 3 halves to the n. That is a geometric series. Absolute value of r is equal to 3 halves, which is greater than or equal to 1, which means it diverges. Therefore, my original series, n equals 1 to infinity, of 4 plus 3 raised to the n over 2 to the n, diverges by dct. So there is my write-up for number 14. Number 15, we've seen ones like this before in 7.7, but we're going to take another run at this. So I'll start with my numerator, and I'm going to start with what I know about sine. So I know that sine is bounded by +1 and -1. And I want to build out this numerator, so I'm going to add 2 to all of these pieces. So I get 1 less than 2 plus sine n, which is less than or equal to 3. And then I'm going to divide everything here by 10 to the n. Okay. And this piece on the end, 3 over 10 to the n, is really 3 times 1 over 10 to the n. So this looks like I have a constant base term, and then I have a number raised to the n. So this is going to be geometric. And my r is 1/10, which is less than 1, so it converges. So I have the bigger piece converging, so I'm all set to do my write-up. My write-up is going to be 0 less than or equal to 2 plus sine n over 10 to the n is less than or equal to 3 times 1/10 to the n. Stick a sense there. And now I got to talk about what this will do as a series. So I have 3 times the series of 1/10 raised to the n, so n equals 1 to infinity. This is a geometric series. Absolute value of r is 1/10, which is less than 1, so I get convergence. So I have the series I'm interested sandwiched in the middle. The bigger series converges, therefore, my original series, n equals 1 to infinity, of 2 plus sine of n all over 10 to the n converges by dct, so direct comparison test. And that is my write-up for that problem.